it wasn't one problem with my other gun. Skill issue. It is very much, well, it's partially a skill issue, partially another gun issue. Last week on Friday, I went to my friend's house to try and fix it. I spent 3 hours taking it apart, putting it back together, and nothing changed about it.
Oh. Like, it would help if we had a screen.
There is, it's like,
So I think the term maybe
the team has like,
Oh wait, whoops. I'm in the wrong notebook.
No.
it moves.
Wait.
it just moved down.
Because I said that.
Yes, that's the same challenge. If you turn it in.
Oh, yeah.
The whole thing.
Well, which 90 degrees?
Which one do you think? Gotta order this thing.
Yeah, the motion's always like tangent to a circle, right?
Yeah.
Along that bottom link.
The angle will be easier to draw. Even if you like fumble with sine and cosine, oh wait, it's the same.
Okay, now we're back. I had the wrong notebook loaded up. I was on top of it. I started on time, but I was in the wrong place. Right time, wrong place. It's always something. But we're wrapping up module 2. Goal for today is like troubleshoot or get individual kind of project 2 4-bar linkage designs explained and wrapped up and shipped out. It's not like a huge in-depth, like none of these projects are like big thesis projects, but it's just like getting some practice, like how do I quantify, how do I take what I see and what I want to do, practice like trying to quantify that and tell people what's important about a design. So that's what we're doing here. So what kind of work were you looking at so far? What kind of designs? Because we can go through like an example. And kind of two ways to approach this is one, like take a look at something that already exists and try to reverse engineer it of like, why does it work that way? Other thing is like, I've got this great idea for a robot that would use a 4-bar linkage for something like robots or mechanisms, and then try to fit that into the process somehow. What were you thinking? Like windshield wiper? Okay. Yeah. So for a windshield wiper, what's important about a windshield wiper? If we come down, we can look at like the path that we have, right, at least from just the given. If we just take the given 4-bar linkage, plot the paths, what do we care about for the windshield wiper? Like in a design, your boss is saying like, design me a windshield wiper, and that's it. Usually that's all you get is like just a very vague description, and then you have to come up with some engineering principles of like, okay, this is why the windshield wiper is good. Sorry, I cut you off.
Well, the windshield wiper needs to go throughout like the whole span of the windshield.
Okay, so maybe like if we look at this orange point B, we want that to go as far as we can. So that means like angle 3 should be as big of a magnitude as we can get it. Something like that. And then maybe some other things that we might care about would be like the speed of our windshield wiper, because roughly we have whatever theta 3 dot is, multiply that by 1 meter, because it's like 3 foot long kind of attachment to it. So if you're talking 100 radians per second as you're trying to drive this thing, now your windshield wiper is moving across your windshield at 100 meters per second, roughly, what is that? 50 miles an hour? Like ballpark? Let's double check. I know it's a factor of 2. Oh, 200, sorry, 200 miles per hour. Right? That's fast. almost speed, what is speed of sound? 600? 300? Exactly. It's Mach 1. Speed of sound. What is it? Oh, 700. So you're doing Mach with a
Like a
half Mach?
That's still fast. That's still fast.
Yeah. I think at that point you're like vaporizing the rain on your windshield. Maybe that's what you want. I don't know. Maybe this is like a military windshield wiper. But just some things to consider. So if I want the orange line to go as far as I can get it, do I want to take, then usually it helps to start with one thing, change one thing, and then change the next thing. Do I want to make L1 bigger or smaller? If I want orange line to get wider, go from the little blue circle. Do I want the little blue circle to be bigger or do I want it to be smaller? What do you think?
I think it goes later. So like a longer pole, so it goes to like a more.
Maybe bigger? Yeah. Let's try bigger. Bigger sounds good. Plus bigger's better, right? So let's make it 3 times the size, like 75 centimeters. And maybe this is all like, if we're talking like a little mechanism in there, maybe we want to make the little mechanism smaller, but anyway, we'll get to that, to like units. First step is just figuring out, oh, it would help to run everything from top to bottom. Did I make theta 3 bigger? Oh yeah, let's look at. Definitely seems bigger, right? Because now it's going like 180 down to 60. So like 110 degrees of. So we did something right? It seems like it's like swinging further along there. That's good. So at one point we have like 30, at its max speed, we have like 30 radians per second. How are we doing on a 1 meter long windshield wiper? How fast is that moving? 30 meters per second, yeah. If we say like our windshield wiper is roughly 1 meter long, the speed of it is going to be 1 meter times number of radians per second. So at some point this thing, for the most part, it's doing like 10 meters per second on average, but it'll fling things at 30 meters per second. Seems fast, yeah. And maybe we need to reduce our drive speed, right? So like, all right, we can't run this thing at 10 radians per second. We got to slow it down. So let's make our drive rate just 1 radian per second.
Wait, that's what that rate was? DA1 is.
Yeah, so this drive rate is like how fast theta 1 dot. So maybe we just want to rotate this one slowly so that the end result is max speed is now 3 meters per second, which seems a little more reasonable for windshield wiper. So we've got a few things that we can play with there. All right, so some wrapping up of like what did I learn in this quick process of like, when I chose the geometry, I plotted the paths and motions because I ran the cells, like I changed things, reran it, now I have some new results. My own wrapping up is that I was trying to build a windshield wiper, so I wanted to increase the range of theta 3 as big as I could. What I figured out was by tripling the length of L1, it increased the range of theta 3. So we went from originally like an arc length of maybe 30 or 40 degrees to now 110 degrees. So much bigger like arc length, better for windshield wiping. So we don't need like 5 windshield wiper or 4 in every corner, just like doing 45 degrees or something. Yeah, so that's how I would wrap up, is kind of pointing to those graphs of, and then also this other part, the other thing that I learned is that I can't run the windshield wiper at 10 radians per second, because then I would have like a 60-mile-an-hour wiper moving across my windshield. So I decreased drive rate from 10 to 1. The 30 went to 3. Now we're saying 6 miles an hour. But the key there, at least like the thing that I'm trying to get across there is like always quantifying, because as the engineer, like you're getting paid to tell a story with numbers. The numbers are your main like selling point. So practice like what was in the graph that you can quantify. Yeah, another question?
I think question you're supposed to read that
How to read it quantitatively?
like it goes negative on both ends. Like negative 3 radians per second.
Yeah.
So it's going negative. I have to go negative on both ends of the spectrum.
What's happening there is, oh, well, it's just repeating. Like if, here, let's do this. If we, instead of like 0 to 2 pi, we can go 0 to 4 pi. And we'll say times 2. Whoop. We end up with the same thing twice.
Okay.
And so then when we get back down to here, now we can see like what happens at that in-between stage. It's like we're looking at a map of the world. It's like, it's not that Alaska and Russia are like opposite sides of the world. They're right next to each other. Yeah. Similar thing here. So yeah, it's not like it went negative but then had to flip up again. It's continuous kind of curve. I don't know if that was your question or if there was something else. But the fact that it's negative positive in terms of like rotation is just whether it's going negative is clockwise, positive is counterclockwise. Cool. All right, let me check in and see what people are working on, and yeah, let's wrap up.
So similar to which how we yeah. Which direction is cosine? Okay.
We just
stupid.
Well, it doesn't matter which way you spin it.
Do you mind if I take
Yeah,
it?
with the graph.
And this is the version. Okay.
The graph is just a
So I can help
reflection of this.
When you put in 8 to 10, you have a second, that's too much.
Okay, also, my other question was like, why do we have to input this E to 2 different places? So he has drive rate, but he also has EA times.
Oh, yeah.
What's that?
If you go negative.
It flips.
Yeah.
What are these, so drive rate is like, what's this value, times 10? Why is this times 10?
Yeah, and like you can change the makeup. I think you can just put in drive rate there.
No, I said I put drive rate as 5.
I did
That's what I'm thinking.
This is exactly where you can go the other. This one, was this one's from class, like the variations of like the something with this they're all like the same number right there. This one, 6 and 7. Like, there's 2 bars. The second bar like is easy. So the next one will take out the one which is probably the least area. But the first will be accurate to the okay. Yeah, so okay. Do you mind if we take a look? Because we can take a look. Oh, yeah.
Oil rig.
We
We could both do oil rigs.
Okay, yeah, ridiculous is good. Like we saw, like if you're, like even here, we kind of saw like with, you can get like increases in speed, kind of like a speed multiplier. So one person was trying to figure out like, could you create like a self-loading catapult out of it, right? So as your crank arm is moving, it loads and then flings up. But you could also think about like, could you make, like wind up horses, ones that sort of like, and the white actually does yeah, so you want your mechanism to be constant. The slow rate of those legs slowly kind of decrease and fling. If you're trying to go for like, you get like bigger is better sort of philosophy, like try to get David to move as fast as you can. Jumps up. Oh, perfect. Yeah, that's a good one. 5 to 10.
Because now,
oh, nice. Yeah. Yes, I bet. Yeah. Perfect. Yeah. Yeah, and you could put a picture of it. Like, hey, this is. Oh, perfect. Yeah, that works.
Find it being exactly awesome.
what is the 4-bar?
Yeah.
I like the portrait.
Yeah.
Where?
No, it's not.
The portrait pencil?
Yeah.
Bicycle suspension.
This one?
Yeah.
Oh, no, that's not.
Yeah, it's not.
You've all done this.
Yeah, so you have like a parallelogram. Nice.
Yeah, I would too.
Okay, that's all right. I understand it. I mean,
No, this is my favorite number.
I don't know how they would get it.
I mean, if you try to make it, this is simply for a just a little bug.
I have my checklist too.
Like you should have.
There's nothing to prevent you from creating like an asshole that is.
Oh my gosh, yeah. would have caught me liking that too, that's the worst part. You really would have. Yeah. Strike that, man.
Yeah.
I switched it over. What is this?
I found an oscillating fence system. It's got literally a little this one.
Oh, yeah. That's a really
It just,
Oh. Yeah.
spinny veg.
Actually, all fans are spinning for here. This one's actually.
No, I mean, not like physically the thing itself spins. I mean,
But then,
what the heck?
it should work.
I think it is working.
Those things working.
Look at this.
Yeah.
Yeah. Piecewise function.
Yeah, I mean, like the way those kind of work is that because the wings themselves. So on the way down, kind of pops up with a great swing. Yeah. Coming out.
So what is radius per second? Like meters?
Radius per second is the rate of rotation.
What are you gonna use per second? How do you guys?
Well, because he said that, say we have more like 1 meter. Take the radians to speed times the distance to not get used. The angular speed times the radius, which is 1 meter. But
Ah.
don't get used to like
We would want like this far to the other.
linear.
I played all of last year. Yeah, I like when I first came out, I played last year. Yes, that's so ridiculous. Yeah. Oh, yeah. So that one looks more.
Yeah, so I think basically you're like moving bar number 2 left and right, so then the other two move.
I think
Your
computer.
This is your system. That's your system.
Yeah. I think this is number 2.
So why is it more?
I can't see it in my book. I think it's because you just built like a perfect square. It's like 4, 10, 4, I'm sorry, 10. You might have to increase like this, but like, or one of them
Really just kind of like add
slightly, or maybe you have to decrease it. It could be your own.
When we change the angle of ours,
You could just check the range.
I tried it, and then I tried it.
This one you 45. Yeah, it's like different. So you can play with.
This should be the easiest one where I linked it, why it doesn't work.
You make them. You make this one like the whole length.
Oh, wait.
90 degrees.
Wait.
It's always parallel.
Yeah.
Maybe one. Or you can kind of bring them in. They keep cooking a little bit longer, breaking like that.
so this is only.
This one changes it by
That's good.
30 degrees.
That's what it's supposed to look like.
I was wondering, like, for the graphs, right?
No, put it back.
It's the same thing.
I'm kind of confused with how.
What is today?
Yeah, and that's what.
Yeah, so that one, this one's
You're
a
finding
little
yourself
different because it's. Let's start with the simple one. I think like travel is because, so we're gonna say, theta one.
It's probably really small. That's one. It's a good line. You look a stupid unit on this. Yeah.
135 or something like 45. Yeah.
They don't get it. That's actually.
Oh, I guess that's the
Yes.
Oh,
Wait, you higher before.
Yeah, it's the worst one.
That's the one.
Oh, guys, I got a text from the TikTok recruitment
So we're
story.
gonna change A1
Minimum daily salary is $300.
from higher to higher.
okay, yeah.
Now we can look at what happens when theta 2
No, it's just a skinny.
balances a class and then theta change. In this case, it should be
I oh shit.
and then we can start playing with like, all right, keep this the same. Yeah.
No, we can't.
Yeah, it's literally just, yeah, we don't, last time it was just that, I'm like, you know, it's way.
We're always in that.
Yeah, in terms of like,
Get a load of this guy.
This is.
Why am I proud of
If you had, like,
I have the question, there's no way to move one past. It's just not possible.
Nine. So I have to wait for my,
windshield.
I wait for my.
So obviously, like, once we go down,
I tried to.
or I guess all of like, but it.
Yeah, well, this guy, oh, cause it like crosses over.
Yeah, it kind of crosses over,
Yeah.
and also like in the video it showed the lengths of it changing because it's gonna stretch.
Yeah.
So I don't think,
It's different.
I don't know how you model
Let's
it.
see how.
I think you wouldn't be able to model with this, you have to be, I think you have the dynamically change dx and dy and the
The
function.
actual angles thing that we care more about is more the range. Because if you think about like let's say I can build a system that goes from here all the way to there. The range is right, but I want it twisted. I want it to actually do this. Twisted by whatever 30 degrees. I could make like a triangle mounted on here. So that
You're doing that.
now this thing, like once I say it's like rigid Y, I can change the initial angles.
That's pretty good.
Bounds, just
But they don't want very much.
Yeah.
just automatically stuff to bounds.
So it's only gonna have, once you have like a geometry and like fixed point setup, it's only gonna have a certain range of motion. And then, like the fact that whether it goes to 0 or it goes to like 15 degrees, doesn't really matter. It's more that it goes from 15 to 190 or something, whatever the range is that you say, this is my windshield wiper. And then the way the windshield wiper gets mounted on there is going to be on some bracket anyway.
Okay, that makes sense.
So it's almost like we're kind of like under the hood of the internal. So that's how you're going to say it.
No, that doesn't make sense.
It's kind of mounted at an angle to get the windshield wiper to the right.
It's not gonna go like right from the beginning.
That's not
Right on the left.
It's like volleyball.
It's just all of them?
Which I know is different, but I was trying to like relate it to mine.
Yeah.
Cause you're talking like like the angle that it can like go, so I was thinking like this one is like the little pedal. And
Oh, nice. Yeah.
Yep, but then I was like trying to get like this part is like wheels like down. Like the range higher, like would the range be like 360? But like this is still spinning.
Well, that one, so for the configuration,
My video, the green one goes 360.
there's no like.
The green one would be L2.
Here, like a continuous moving gear that keeps them.
So I need to change the rate of L2, I can't have L1 oscillate.
Your the bottom plate is the femur.
So I just tried that.
Oh, okay.
So that there is kind of different.
You can
You're
change
not,
out
so the bite is not drying.
There's no
You're drying.
I did from 30 to 130, but then my graph is just linear. It doesn't show up L2.
Yeah, up and down, that's how it's spinning.
Okay, that makes sense.
Yeah. Yeah, and that would work too, it makes sense. So you have the same L1, but now the mounting is sort of like your butt is point C.
Yeah.
And your legs, your knee is point B. Yeah.
Okay, so like then like would just like these parts be like longer and like this one would be like shorter?
Yeah, that one, so that like second one would be almost like vertical. That would be from like your foot to here. And then this link, the connector, or sorry, this is your rocker. Is your hip to your knee.
I didn't change the function.
Yeah.
So for the, like, view that's going to do mine, we'll just do that with the original. It's also with the marshmallow.
Yeah, there would be like some DX and UI there, but it's always cheap.
Okay.
Yeah,
That does
the
not.
only one that's fixed.
Okay.
So, and it's not that like the origin is always in a 0-0 location. You can put it wherever you want. This is just something. They just limit how much design is called to consider.
Okay.
Yeah. Alright, how's it going? Yeah.
I have pretty easy one.
Okay.
So I'm trying to run the oil rig.
Yeah.
I end up with this guy. I think this is right. I can't tell.
Okay.
I modeled it based off this video.
Yeah.
Just kind of like took the ratio of the lengths.
Okay. And what, for an oil rig, what's like design standard?
I actually have no idea. That's
Yeah.
I'm kind of confused.
Okay.
It looks up like average rotation.
These are
And
Yeah.
RPM converted to like 5, so it's like 5.
Okay.
Right?
Yeah.
We don't have to change this value, do we?
That one will change, yeah, if you change that to 5, it'll update, the graph below, like here, now you have a 5.
Okay.
Yeah.
That's how you sure how I'm supposed to interpret this flip.
Mm-hmm.
This looks like it works. This oscillates back and forth.
Yeah,
This is the base. And this
yeah, we're
goes
kind of looking at it like
sideways. I wanted to be intentional.
sideways.
It's I was trying to model this just in the opposite, like I flip it
I mean, they're.
around the axis. You know what I mean? Like this, this just moves to here.
Those are bonds.
Is this sideways or like upside down?
So if we have. This is that.
Oh, that was not the intention.
So because you had O and C. See how they're both like on the x-axis.
How do I fix it?
Oh, do you? I mean, you
I
can.
want it, I kind of want it to look like this.
If you want it to look like that, then you need some kind of positive.
This one had broken zipper.
Maybe that.
Broken strap.
Whether it's negative or
It's like just, there's no DY, it's just
to
DX.
say that point C is not
Again, like,
now the same location.
yeah, because like, you're like looking at a.
So where you want it
DX
to
is like the bottom of the.
Oh, I see, the DX.
Doesn't matter which one of that is not.
Yeah.
So this is 4.
So I was thinking like, this part's the DX, that's like constant, so then there would be no DY difference. So then, I just don't know how to represent it. They can, because they're on the side. Like if 4 bar look at like a 1D, or like a 2D plane, I don't know if that works.
Yeah, they're dimensions, like,
Yeah.
just like the front to the back.
Yeah, like from across.
Yeah.
So in this video, it's like it stretches, it doesn't just stay there. Like this one, this is constantly changing. Like 1 point, but then
Because what I did was like I measured the first one. And then I measured the actual side. Like right off the start.
What is nice is
So just keep running through and look at what it looks like.
so she
you see, it's like the system.
This is right, it's like,
If you say that I want to here, this is what you tell to right now, this is between they see like this yellow.
it's okay if this one is a mirror, this one up symmetrical about the y-axis.
Actually,
That's
it's like
okay.
PCL art.
But I didn't know before.
Changing it. This one's kind of like, I was like, I was like, say that, it's like,
Along the y equals x.
just leave,
Yeah.
you just full rotation, 10 radians per second. That's really
luckily I like the way around. No, I like that better my mom. Again, so when
Wait, how'd you do
That one. This is an initial guess for what the angles are. Say it's 2 and -3.
Okay.
Because there's an infinite number of solutions. If you think of like when this solution equals 0.
Okay.
Well, so each of 0.
So is this the same? I think it's just rotated about the y-axis.
Yeah.
So this guy would still have like this graph, or during this graph?
Yeah, so just so we're gonna like pump it up and down like that.
It's not like define the.
Oh, then it's attached to something else, right?
Yes.
Which race is like.
Okay, so only goes like, so if I like extended it, like extended it this way?
Because like if you
Extend
want
it this way.
Yeah, so what they do like in an oil field is on the other side of this is a big mass. So it moves it up and then pushes it down.
Yeah, we
Yeah.
So that
I
makes
think it
sense.
saves
Yeah.
going to.
I guess
Code
my
is
other question would be like,
whatever
has
the
the design stuff, these things are a little arbitrary, although it does work. So how, I didn't quite
Yeah,
understand how you
I
interpreting
should say
How are you interpreting this?
Like what is it,
Yeah, so you have theta dots, you want like theta dots like an arc circles. To get
Yeah.
to get the meters per second
So
velocity.
in this case, when we like
save which
mount this like giant thing up here, yeah, that's where like our pump is. So down here is like
Yeah, so
this
hopefully
like creating pressure, like push oil up into something.
Okay.
So let's say this big long arm is 4 meters. Now I know that these theta 3 dots, because this is telling me theta 3, whatever theta 3 is, that is my arm.
Because it's reading per second,
Yeah.
It's a good try.
So now I know that on the downswing,
It's going this fast.
I guess it depends, right? Yeah.
Well, shouldn't the highest velocity be on the?
Yeah.
Which one, like?
It looks like it moves faster on the swing. So that is right now. I don't know, never tried to. But
So I have what should have been a very easy.
yeah.
So I went with a steam locomotive.
Okay.
That has the linkage between the two wheels.
Yep.
The two
Yeah,
radii.
that makes sense.
So you would imagine that it should be dx is the same as L2.
dx is L2. Okay.
And then L1 and L3 are equal to the wheels.
Okay.
And when I do that,
Oh yeah, because it's kinematic problems. Yeah.
so when I get to that looks okay.
Yeah. Do you know what's happening?
Not exactly.
So you end up in like a so if I have
Oh, I think I want to change it.
so as this thing kind of comes down, everything's in line.
Like it wasn't gender. They don't want
Yeah. It
But
could
they do.
come back up like this.
Yeah.
And that's just
Yeah.
but your solution of just making one slightly smaller, that one works, right?
Well,
Or no?
I'll show you what.
All set?
Yeah.
No question?
I started my other class like 20 minutes across campus, so I can start walking.
Okay, yeah, yeah.
So if I put 3.9 is that's basically 4, right? Yeah, that's full circle, which is how it should look, right?
Yeah, that's what you wanted.
This, I think that's okay, because that's just, theta is just increasing because spinning. So
Yeah.
that's why that's like that.
Well, think about if theta dot is a constant slope, what is the theta look like?
But what do you mean constant slope?
So if you have a constant velocity, what does your position look like?
Oh, okay, so it's increasing.
So that's what we're saying here, that theta 3 is a constant velocity.
So that looks okay.
Okay.
And then that looks okay. When I got to the last,
Oh, there's a little.
because research was so I don't know if I should just say that it's just a limitation.
So what that is like, submit it like, task one, and like, don't give feedback. Because he might write out.
I changed it to 5, -5, and ended up positive.
Well done.
Yeah, just right up. I didn't positive. And then I thought maybe changing L1 to 3.999 and see what that would do. But I didn't track that one.
Yeah, we're definitely giving us.
Well, the red part's just
One way to avoid it. This,
Oh, yeah, I got the.
no, it doesn't like that easy. It doesn't like 0 keys.
Other than that, it's I get what it's trying to show.
Yeah.
But I was just surprised, like, oh, this is a pretty easy form. I like it. Like, square.
Yeah.
Yeah, like, did it have you inert?
I'll try it. I don't want to try to see what happens if I change.
They were into like person.
It's like every.
Yeah.
You're watching, yeah.
Yeah. Yeah, I think he's good.
Wait, should
Yeah.
this always look like a sign?
Actually, I would want like.
No, it's not gonna be like a sign wave unless you have like specific geometries, because it's a combination of like 3 different paths.
Okay.
And there's like 3 different sine waves all added together.
How did you know it's like going this speed on the way up?
So I'm thinking like it's positive is
Going up?
curling this way, so it would be this.
So if I spun this in the opposite direction, you think they could fix it?
That's good.
Which variable is that?
The drag.
It's like finding.
I mean, do I have to change the other one as well?
I think you would just change
Who's the.
that 10 to a negative.
Or you feel like drag X at 5, so change it to -5?
Yeah, and then negative 5%.
I think it's 6, but I think that's
Still.
So I can do a different linkage.
I think the range was like 50 cents.
Fine, because I think for the most part, what happens, even when it wants to like zigzag like that, is there's momentum that brings it through. We're not really considering like momentum in this case, but just
Well, also, I know.
Tomorrow it's gonna be. Feels like it's gonna be 8 hours of it.
Yeah. Yeah, because then like it would like bring one of the wheels and start rotating in the opposite direction. For the most part.
I'm having trouble interpreting it. So it's going faster when it's negative.
Yeah, you're right. Yeah.
So would that like imply, I And now all it did was actually flip the graph upside down.
Yeah,
So now it's moving faster over time. It genuinely has no idea.
so now positive is that way, negative is that way. It's just getting down, so I think you can't see that down.
So now I guess when I do the right, trend line over. I don't think I put that number like what speed the kiss is going down.
Yeah.
It says that like rocker arm rotates like 20 RPM. Okay.
Yeah.
What I just would that be my data top?
That's your data dot.
Okay.
This is a station.
That's my current.
Yeah,
So I just convert that to.
hypothetically, if you just,
This one's just.
Where that's ready
so I'm saying you pretended that this was the stationary one.
I appreciate it. So the Reddit didn't have to be like a super.
Why?
It shouldn't be too long. The main thing is just graphing like the important values out of your graph.
Okay.
So for this,
Yeah.
I mean, with Ellery.
if you're okay with the mistakes that Cass is doing,
I mean, like, it's fine to write it up, but like, okay, look, this is doing what I wanted to do. But there's definitely numerical, like, things happening that I'm not, that I don't think would happen. Like, I think momentum would kind of take care of these, like, little whatever. Yeah.
because if you're fine with it, I'll do it. I just don't know how the TAs will see it.
I mean, if there's an issue, like,
I think you
if
can write it up
TAs
in the
give you-
box.
Yeah.
Right, what?
Like, if they give you feedback, like, hey, you said this, but it's actually something else, then part of that might just be like, all right, let me re-clarify what I was trying to say. Right?
I mean, as long as it's just fine to do.
Yeah, it's fine, yeah. Sorry. How's it going?
Yeah.
trying to get an arm, like cranking something or
Oh, so, like, so you want to say the geometry, but you want it to go down this way? No, I mean, if that's what it's doing, what you're thinking.
What's the and over now? Like end of one.
So I could,
What we need to change is actually. So instead of our initial guess, like, right now, this is
like my work with you, I think it's 50.
and that is zero.
Yeah, look.
You don't shoot which No. Kill her, how read those tables.
Something changed. Now.
Oh, why? I would
like that, right? Yeah. Like that one, like we were just talking about something similar, so at least like the way this is. Yeah, okay, yeah. Oh, so you're thinking like.
Was it like this? Like this?
Yeah, alright.
A semicircle?
Yeah, so your elbows moving that, and then your forearm, that's the pattern. Cool.
So this, why would you say?
Yeah, like your
Should we type it up in here or like on paper? Take a picture?
Right now? I guess if you want, like, if you wanted, you could create your own like document and then copy the draft so that it's both this and to your own writing. Or and like writing.
How much time do you wait to that goes?
I mean, well, take down show you whatever you rate. Yeah, exactly. Yeah.
Okay.
Cool. Yeah.
And?
I'd like to listen to a quick question.
Yeah.
I'm doing a offloading band for our linkage.
Oh,
With
cool.
this system, it's theta 2 that's actually rotating a 360-degree manner. So how would I modify my program
So there,
work?
like, it's okay to leave it the way it is, like, because right now we're not saying that, our whole setup is that, point O and point C are fixed, but in this case, really, it's like point B and C are fixed, and then the rest of it is all rotating.
Yeah.
But it's okay to leave it this way, because the main thing that we care about would be.
When, like, with my drawing as well,
Well, that's not the album thing.
I can just rotate it like 90 degrees, so that's still the point O and point C are fixed. I can figure out how to get L2 to rotate to.
So
It's a long album.
where was that
The
video?
That like is it a slow song?
It's in the middle of the video.
It's a slow song.
So like as this
The rest of it goes back and forth.
yeah. I'm trying to figure out which
What is it?
mostly we care about the range of motion of, I think these are it's like bigger data.
Like when I tried it first, I tried to just oscillate from the thing of 1 from like 50 to like 130 degrees, but that didn't get the right motion.
Now, yeah, you're trying to do this to get
It was
what really, this is still like,
He barely talked about
yeah, so the main thing is, you can think of it as like, crank arm is big, and the rest of the base is the bigger, bigger theta 2 or theta 3, bigger range of motion.
Probably just messing around with this. Thank you.
Oh, okay, yeah. So those are going to be 2 separate pictures. Okay.
No, so it's beautiful. I wonder, someone will.
So it's going to be like a cake twisted out of the page. It's not like, you can't say toward it's going that way. That tells you kind of how to sort it. Yeah. Then like if you wanted to like use page, then plus minus that, there's no distance. So then you'll have some of the moments is we have like 2 tensions, like a tension and tension. So that torque due to the tension and then on the other side, see the rest of it. Yeah. Oh, yeah. Like right now.
Still recording. Stop this.